Good afternoon, everyone. First, I would like to thank the AIT for having me here, especially to Dr. Monco. And in this talk, I'm going to present one little experiment we did in Spain in my research group about a merge between two approaches in AI that usually are not merged in current applications. In one application domain we selected, that is climate change. As I was saying, in this talk, I will present some work we did in the last months about integrating generative AI on the one hand, and symbolic knowledge representation through ontologies, with the purpose of detecting fake news on social media. I must say that what we call fake news, usually, people specialized in communication have subcategories of what we call fake news, okay? So, to be more rigorous, we can say that this system is useful for detect misinformation, more generally, okay? But in the media, we usually say the term fake news. As we will demonstrate later on in this talk, in this experiment, we achieved a better accuracy and explainability than other systems which are similar somehow to ours, as I will explain later. As you can see in the diagram, on the one hand, we used generative AI, and on the other, environmental ontologies, both available and accessible through the internet. So everyone can repeat our experiment if they want to, and we are building now a data set to be accessible through the internet in the next months. Okay, about social media, as all of you know, probably, we can say that it's a major source of news today. Most of us get informed through digital media, usually, social media. But we already know that this system, I mean social media, facilitates the spread of misinformation. In particular, in the domain of environmental issues, such as contamination or climate change, there is a lot of misinformation in the social media. And we usually don't pay enough attention to that, okay? In there, you can see in the figure like an iceberg, okay? And we are aware probably about the upper level, misinformation spread, but we are not aware about the mechanisms behind that. Basically, three mechanisms, which is algorithmic bias. So now it is common, for example, that in when there is software implementation, there should be people involved in the team of developing the software, who are not specialized in ITs. They can be in sociology, political science, and so on, to avoid this kind of algorithmic bias. Also, by its very nature, social media, they act as echo chambers. So everything is amplified. Everything written there is propagated very quickly and very widely, okay? And thirdly, there is a lack of verification, usually. Even users, we should verify all information we get from social media. But we usually don't do it. Okay, so these three factors don't help to the propagation of misinformation. This kind of misinformation, I mean environmental misinformation, can be said to be often subtle, pseudoscientific, partially true. So it's even hard for a normal person to detect. If it's hard to detect for a human, imagine for an artificial system. Okay? So we had to address this kind of factors in our experiment. On the other hand, we know that generative AI models are powerful enough to face great amounts of data and to extract patterns from that and so on, but lack factual grounding. So they depend on data, not facts. Okay. On the other hand, we know that ontologies provide structured domain knowledge. Just in case you are not familiarized with ontologies, one ontology can be said to be like a knowledge graph. I guess all of you know knowledge graphs, but with added information about the domain. For example, through axioms, logical rules that make statements, logical statements about the domain. So it's much more complex than a knowledge graph, okay? So by taking into account this complexity, we decided to create a hybrid system that enhances fake news detection through the combination of generative models with environmental ontologies that are available, freely accessible through the internet. Okay, why? Because on the one hand, we have generative models capacity to create realistic fake news or misinformation. Okay, and on the other hand, we have that environmental ontologies can provide contextual knowledge. So in other words, what we assume is that what is in the ontologies is truth, okay? Usually those ontologies, I mean ontologies which are accessible through the internet, have been validated by not only one expert, but the community of experts. So we should believe in that. Yeah? Someone could say, but all of them can be wrong. Yes, that's true. One full community can be wrong. Imagine about scientific theories, from time to time they change. So it means that the previous community was wrong. Previous community of scientists were wrong. Yeah, but that is why I said that this is an assumption. That's why I talk about factual knowledge, okay? But still, anything can be criticized. So, what we did, basically, it can be explained through this scheme, okay? We collected data. I will explain later how. Then from those data, we extracted claims about climate change. Then we aligned what we extracted with the ontologies I was referring to. Then we did classification and then evaluation of the system. No? Classification of the information we extracted to see if it's wrong or not, if it's misinformation or not. So the process was not complicated from my point of view. The typical way to proceed, I would say. Okay, let's go a little bit inside of the process. Data sets were collected from several sources, basically 4 kinds of sources. X platform, or Twitter, Facebook platform, and then 2 benchmarked sources that have to do with misinformation in this domain, which is Fake News Net and Climate Fever. Probably that is new for most of you. Of course, not Twitter and Facebook, but the other 2. Fake News Net is a benchmark dataset which is useful for detecting fake news, okay, in general, because usually they have like some patterns. I mean, misinformation follow usually some rules. But we also used another more specific database, which is, or data set, which is Climate Fever. Climate Fever is a data set for climate change, misinformation analysis. Okay, so it's specialized exactly in our domain. And the rest, Twitter data and Facebook data is the normal way to proceed, I would say. Okay. In Twitter, we use trending topics to be more specific, and also user sentiments. We focused on that. And in Facebook data, extensive user engagement and content sharing patterns. Okay, so we focused on those facets in the social media. How many? Well, we, as I said in the beginning, we made a little experiment. So we only took 1,500 fake posts. This is small. It's big for us because we were 3 people working in this, but small for the billion of users consuming misinformation every day, okay? And these posts, these 1,500, were posts verified as fake news, okay? And we also took 2,000 articles, 2,000 real articles, articles from reputable news sources, from usually scientific journals. Let's go a little bit more in depth now. Okay, as I said in the data sources, I already commented about the collection method. We use keyword-based scrapping, okay, manually and with some tools. I will comment later on. And benchmark datasets. These 2 I commented, okay? Climate Fever and Fake News Net. The labeling strategy consisted of labeling as true, false, or misleading, and we use some available tools, not to do it everything manually, like Snopes, Polyfact, Climate Feedback, but also expert review. Okay? These tools, you can find them in the internet also, these tools I'm commenting. Language, we focused only on English, which is the most used in the internet still. But ontology sources, in the beginning we explored several, not only 2. But we explored Envo, Suite from NASA, GMET from IEA, and Agrovoc. But in the end, we selected only 2 of them, Envo and Agrovoc. About the ontological techniques, that maybe you are less familiarized with that, but which is essential in this research. We use name entity recognition methodology, which consists giving a text to detect the entities about which the text is semantically talking or expressing, okay? Then entity linking, so the relationships between the detected entities, that's how NER works. Then we did semantic similarity with some tools also, like Spacy and WordNet. And then we could build rule-based consistency checks. Okay. So here is the kernel of the ontological work we did. Okay, it has nothing to do with generative AI. This is the complementary to generative AI. I can advance the results. So 65 of claims aligned to at least one ontology. So it means that the ontologies we used were quite good. Okay. And about the validation outcomes, 73% of false claims flagged as inconsistent with environmental knowledge. Okay, so this is before implementing our system, the data preprocessing. Okay. As I said, from the information I have from the public here, as you are not very familiarized with ontologies, maybe I'm wrong. Are you familiarized with ontologies? All of you? No. Okay. Then I will give a little more of information about each ontology we used, because it is essential to understand this approach. About Envo, I give here the information about the maintainer or publisher, okay? Because OVO Foundry is quite famous in the scientific community of ontologies. It has about 6,000 concepts. The relationships covered in that ontology include is-A, so taxonomies, part of, that is partonymies, has role, has material basis, etc. These are the most important. The format access can be accessed through ontology web language, which is OWL. The acronym is OWL. OBO, ontology, biological ontology. Object, sorry. RDF, resource description format, is accessible through other tools that can be found, like OntoB and OLS. And then I describe also the key domain coverage. It covers ecosystems, habitats, environmental processes. Okay. I remind you that we focused on climate change. The suite ontology was developed by NASA and ASA. It has more than 7,000 classes and is distributed in 20 subcategories or modules. Okay. They have relationships defined in a different way than Envo. They talk about broader, narrower, related, physical process, and so on. Also, it can be accessed through OWL. OWL is the standard language for ontologies, so that software programs can understand the contents of ontologies. And it has been used for Earth system science, geophysics, atmosphere, and climate. So quite pure scientific ontology. About GMIT is more or less the same size as the previous ones. It's about 5,000 concepts, and it has relationships similar to the previous one, like broader, narrower, related. Okay, this can be accessed either through SKOS format or AgroPortal. AgroPortal is very popular website for information about agriculture. The good thing of this ontology is that because it was developed by the European Environment Agency, it is multilingual, not only in English, and it also cover waste, energy, and water, and ecosystems. And to end, the agrovolk ontology is the biggest. It has about 40,000 concepts. It's also multilingual, and it has relationships also similar to the two previous ones, like broader term, narrower term, related term, and so on. And it has been used for agriculture, food land use, biodiversity, and so on. So as you can see here, there is nothing specific about climate change. No, when in the last column, you cannot find the term climate change, but this terminology is very relevant for climate change. Okay, so all of them were quite relevant. Following with the methodology, what we did then. So far I have explained the pillars of the methodology, but how did we use exactly the methodology apart from applying named entity recognition to the selected data? Okay, we selected GPT-4. It's one of the current most used generative AI methodology, so that it was fine-tuned to extract factual claims, because we knew which claims were true or not. Remember that we did preprocessing, data preprocessing in the beginning, from noisy, informal social media posts, okay? And then we did data filtering, claim extraction, fact verification on the data, as I explained before. The architecture of GPT-4, probably you have been dealing with that, so on, but we can say by summarizing that about reasoning, about coherence, sorry, it has a better contextual understanding and generation, and it's in green because that is the feature that grounded our selection, basically. The other two features in reasoning and scale are okay also for our experiment, because it has a powerful logic engine and analytical capabilities, and also about the scale, it can be enhanced for broader knowledge. So it's modular, extensible. So that's why we selected this, GPT-4. About the ontological methodology, as we said, from the 4 ontologies I explained, we selected Envo and Suite from the 4. Let's go back to explain the first 2. Okay, why? Because the first, Envo, contains explicitly the very standard relationships in ontology modeling or ontology engineering, which is A, so for taxonomies, part of taxonomies, etc. Okay, and the second one, because it's similar to the previous one in size, and it incorporates complementary relationships in relation to the previous ontology, which is broader, narrower, related physical process. And also the key domains, in our opinion, are closer to our goal, which is climate change. So we decided to use these 2, Envo and Suite. Okay, then what to do with the ontologies? Then we used to align the data we were extracting from the posts and tweets, okay? Which kind of data? We classified manually first, and then train the system with biological data, ecological data, biomedical data, and environmental data, because the ENVO ontology is categorized like that. And about the suite ontology, we, in this case, is a little bit more structured, because it's for Earth and environmental terminology. So it is structured around concepts, properties, relationships, okay? But also semantic web technologies to use it. It provides also this. So advices about which tools we should use to make a good use of them. Also, we use random forest classifier, the integrated linguistic and ontological features for improved classification, okay, of the data. By taking into account amongst the linguistic features boost classification accuracy significantly, and ontological features enhance classification precision in an effective way. Okay, so both linguistic and ontological features were considered. We used then a web-based single-page application. My postdoc was in charge of the implementation and used ESPA, which is single-page application for content input, analysis, result visualization. And we used some tools we found, open source, of course, Tailwinds, CSS, and JavaScript. Okay. The ontology-based entity extraction contextualizes user input using environmental concepts. Okay. So we made sure that the data were relevant for our domain. Okay. And also, we used a BERT-based model to classify input as real or fake, with confidence score and chart JS visualization, okay? Between low confidence and high confidence, the extremes, okay? On the one hand, in another dimension, real classification or fake classification. So about the BERT model, maybe you are, I'm sure you are familiar with this. This is a previous model used in generative AI, basically. So in summary, we can say that an LLM-based summarizer provides a concise, human-readable summaries of classified content based on all what we have been, I have been explaining here. Technology, classified content, random forest, and so on, and human readability through the ontologies. Okay, well, this is about how large language models work, but you have been dealing with this in these days, so it's not for this application, but general, okay? This. Then we implemented a small prototype to be validated. Actually, I said in the beginning that we are trying to put the data set accessible and so on, and also this system. In the next months, I hope it can be accessed so that the input is social media posts. Then inside there is text preprocessing, and inside also that's why it is in white. This is like a black box for the user, okay? As I have been saying here, there is a generative AI model, which is GPT-4, and environmental ontology. And these two ontologies we selected, okay? And then it responds to the social media post if it's misinformation, so fake or deep fake, or if it's true. Okay, so simple simple system from the user point of view. And the main interface of the prototype is, as you can see there, for example, one text from social media, real text, said that climate change is a hoax created by environmentalists to gain funding, or industrial CO2 emissions are accelerating global warming. Okay. Then the user clicks on analyze text, and then this is the output. Okay. The analysis results with a confidence classification and explanation summary. Okay. So it says that with a probability of 83% is a real information. And so based on factual knowledge. That's the meaning. And it would say the text addresses general environmental topics. Deep analysis is required for a definitive classification, but it contains no obvious disinformation matters. So it is honest, because here it's not 100%. So still 17% of uncertainty. So that's why that explanation summary, okay? Let's go to another example. No? According to the Institute of Totally, I think you can read from there, but in case it's too small for those of you far away from here, it says, like, according to the Institute of Totally Real Environmental Science, crops exposed to daily compliments like you are the most photosynthetic. Okay. Okay. Compliments like you are the most photosynthetically efficient wheat I've ever seen, and your chlorophyll is glowing today, have started absorbing 3 times more CO2 than normal. The phenomenon now, dubbed agri-viticulture, is being hailed as the most groundbreaking environmental breakthrough of the century. No? Even for one person who is not familiarized with this is strange. First, that institute is the first time I hear about that. And second, the terminology used is complicated, not easy to understand, but not for scientific reasons, but for other contextual reasons. So intuitively, this is strange. No? And our system analyzed and said that with 92% of probability, it's misinformation. No? We tagged as fake. The reason for that, on the right hand, explanation summary, fake institutions. Okay, so starting with totally real environmental science. The Institute of Totally Real Environmental Science. That's a fake institution, it doesn't exist. So far, no? According to the databases, so the ontologies, in the ontologies, they also contain information about institutes relevant for climate change, but there was nothing like that. Okay, as I said in the beginning, our ontologies cannot be said to be the absolute truth and forever, because knowledge is ever growing, being modified, etc. But if we assume that, it's almost 100% misinformation. Okay, to end this talk, we have evaluated our system effectiveness through the typical parameters like precision, recall, and F1 measure, okay? Where TP stands for true positives, FP for false positives, Fn for false negatives, okay? And we got reasonable good results, as you can see here. Okay. I repeat that this is a small experiment, so not statistically significant so far, and I will self-criticize this later on, even, apart from the things you can say. Also, we detected that ontology integration identified contradictions with established environmental facts, so inconsistencies. That's why, for example, that post was with 92% of probability a fake or misinformation, for example. Okay. We also compared the effectiveness of our prototype with others available in some journals we found, okay? And for example, in terms of generative AI, we repeat it with other systems alone. So this is not an evaluation study, but we changed, we compared with using alone, so without ontologies, other systems. And for all parameters, ours was better. Okay. I mean, in terms of precision, recall, and so on. The one we used is, for example, we used only one ontology. Well, ours was the last one. We use Roberta and we use Bert. Alone, without ontologies. With the ontology alignment, I introduced in the beginning what was that, the concept of ontology alignment, enabled semantic validation of 65% of claims and flagged 73% of falsehoods. Okay, so 73 false claims identified, claims validated successfully, and were over 50%. We would like to be 100% in all of them, but I'm telling you what we got. So it means that we need to improve. Even if compared to other tools is better, but to be applied in a real setting is not enough in our perspective, okay? Because still we are not totally sure. Now I talk about an ablation study, okay? Ablation, so it means that I took a part and I tried to analyze the effects of substituting that part in the whole system, okay? So I don't compare with other tools, but with our, I mean, parts of our system with the whole system, okay? Just in case you are not familiarized with ablation evaluation. About the performance, okay, here you can say that the full hybrid model, the effectiveness is almost 90%. So it says if it's false or it's a fake or misinformation or not in the 90% of cases. That's what the meaning. Without, if we take the ontology part, if we remove the ontology part from our system, the effectiveness gets down to 83%. So with the generative AI model solely, we only get answers for the 80% 83% of cases. If we remove the generative AI and only use the ontologies, we get 80% of answers, which is not bad either. And if we remove both the things and we use traditional ways, a rule-based system or whatever, it decreases up to 86%. So it means that it makes sense to merge these two things, ontologies and generative AI, apart from other systems in the literature, okay? Apart from that. More critics, so more limitations we detected in this approach. Generative AI structured factual claims effectively, but struggled with sarcasm and colloquialism. So we saw that it doesn't work properly, because a lot of posts, a lot of tweets contain sarcasm, because we are humans, we are not scientists, usually. I mean, most users of social media are not scientists. And people in our daily life, we use a lot of sarcasm, a lot of colloquialism. So this system didn't detect that. Why? Because it's much more difficult for that. We would need other kind of ontologies to detect factual knowledge about that, for example. Okay. Colloquialism. It means that only people familiar with some terms understand the topic being dealt with. Okay, so that's another weakness of this system we have to deal with in the future. Okay. In this scheme, you can see how generative AI systems behave in relation to these two things. Okay. Of course, the good things you have been seeing these 3 days, the good things of generative AI. But with one exception, no? The talk about Professor Olga from the Netherlands, she also criticized LLMs for detecting cyber attacks, if you remember, okay? So she also criticized the goodness of generative AI in all things. So in this case, here on the left, I say the good things of generative AI for this, but I say also here the bad things, the limitations of generative AI in this application domain. How about ontologies? Okay, ontologies ensured semantic precision and alignment with scientific taxonomies. Remember that the ontologies we selected are grounded on science, not on opinions, okay? On science. So we can say 3 things, basically. There is consistency with scientific classifications, which is good, accuracy in meaning representation, and frameworks for semantic precision, okay? So all things are good in this sense. But what is bad? What I said before, that we need also ontologies for sarcasm and colloquialism. Because in this case, the ontologies cannot be used or are not useful for us. Anyway, we can say that the hybrid model demonstrated superior performance due to the synergy between neural and symbolic methods. Okay. Of course, neural refers to GPT-4, and symbolic refers to ontologies. Okay, in this case, there are other neural models and there are other symbolic methods. Okay, I selected just 2 representative of each category of approach for AI. Also, we didn't work on in real time, and could be good also. In fact, it would be wonderful to have a tool that can work in real time, So analyze social media in real time, okay? That would be much more practical in society than just taking historical data from social media, for example. Another limitation is that we focused on English only, okay? There are many other languages in the world, and just in case someone doesn't know, whenever a language disappears, I mean, from reality, from some analysis or whatever, there are things that cannot be expressed totally, apart from science. I'm not talking about science, but social media contain, as I said, sarcasm, colloquialism, and that is culture dependent. So the way we use sarcasm is different here than in Spain, than in India. So if we focus only in English, we have limitations of the English language to express emotional information, which is sarcasm is a case of emotional language, okay? And also, we focused on text. How about videos or podcasts? Okay, so there are many, many things that can be researched in the next months or years in my group or in collaboration with some of you. All of you are welcome to collaborate with Dr. Moncol and with me. And here I put exactly the topic research, okay, that this work could lead to. The conclusion, okay, so is that a hybrid AI framework enhances fake news detection or misinformation detection by combining generative language models and ontologies. So it has been demonstrated through this experiment. Results demonstrate that that approach improved accuracy and explainability with direct applications in critical domains. If we assume that climate change is a critical domain, I think everybody agrees on that, okay? Because we are seeing almost every day the effects of negative effects of climate change, okay? So we can say that there is an inaccurate black box in this problem we dealt with. There is a need of applying new methods and techniques about the implementation, and we hope to achieve accuracy, better accuracy and explainability. With ontologies already we have explainability, okay? But still we need more. So, future research directions. So if we use scientific terminologies in the field, in AI, we can say these three. Adaptive fact-checking, so that consists on developing flexible verification methods, multi-language support, and enhancing accessibility across languages, not only English, and multimodal misinformation, addressing misinformation in various media, okay? In terms of videos, podcasts. Also, we can say that this framework contributes to trustworthy AI by for combating misinformation in environmental discourse. Okay, this is the scheme I already put in the beginning. Okay, and simple architecture, but powerful, enough to be developed in the future. Okay. In this sense, what can we do? Exactly, I mean, as research topics for future papers in our group or in collaboration with some of you, For example, if some of you come to study a PhD, my university can deal with this, okay? Dr. Monco already has the information for that. So we can deal in 4 possible directions. Adaptation to visual misinformation, so which consists of doing research for adapting to identify misinformation in visual content. Remember that what we did is just text, but how about the visual content? Because we are creatures that depend a lot on what we see, more than text. Because if we read a text and then we see something different from what we read, we usually pay more attention to what we see than to what we read. Okay, so this would be the first research topic as a continuation of this research. Second one, dynamic expansion of ontological knowledge bases. So if someone prefers to work in ontologies, because here there is a space for everything. Generative AI, computer vision, which is the first one. Second one is about ontologies. So dynamic expansion of ontological knowledge bases consisting of expanding knowledge bases to include new information. Okay, they are big enough, yes, 600 or 700 concepts, 2 ontologies, but it's still not enough. I said that problems with sarcasm, with colloquialism, so it means that it's not enough. And even we dismissed 2 ontologies explored in the beginning, because too much work, because we had to explore one by one, manually, in the concepts, to see if they are relevant or not for our goal, okay? So, if someone prefers to work in symbolic AI, there is also a space here. But there are more things, 2 more things. Adaptation to cross-lingual misinformation, which consists of adjusting to detect misinformation in multiple languages, which would be nice, that you can use Thai, you can use Hindi, you can use Mandarin also to detect misinformation in those languages, okay? Which is typically is very different. Misinformation in China is not the same as misinformation in Europe or in the US. So the way the text is, the kind of misinformation and so on has cultural dependence, okay? And the last we envision is incorporation of temporal reasoning. So someone who likes logics has here a good space, a good scope to develop some research. Because it consists of integrating time-based analysis for a better understanding. What does it mean? It means that social media information varies over time. But also, as a user, what you say today is different from what you say tomorrow, but there can be relationships between what you said yesterday and what you say tomorrow, and so on. So it would be interesting to follow the discourse, individual discourse and community discourse at those levels. This one maybe is the most difficult to address, but it's the most powerful too, because it would detect inconsistencies in groups of communities as a whole, but also in individuals. So imagine you are interested in knowing if you are consistent with yourself in what you say. By using this, you can know yourself better also, to see if you are being consistent or not in your discourse, okay? And that's all. I would be pleased to answer any questions you may have about what I have been saying, about future collaboration or whatever.
Thank you so much for the presentation. It was very insightful. I'm just wondering, you took the data set from the social media, right? So basically from the Twitter, Facebook, right?
Mm-hmm.
So you have mentioned that, yeah, the there is kind of like inconsistency between the ontology, right?
Mm-hmm.
So, and the generated news, right? And, right.
Right.
You're saying like the sarcasm and the colloquialism that are impacting, right? So in the social media, like people write in shorthands, right? Shorthands, they use shorthands, right? And just like you said, maybe there is kind of like temporary relationship. Whatever they write today, maybe that is following up next day, right? Have you also like consider, or do you think like will it be useful if you also embed the user persona or user positions or belief, those things into the user profiling things into the system that will gain more confident to classify the news?
Semantically, yes, but by taking into account privacy issues, not. I mean, this means more private information into the social media. So if you are in Europe, maybe yes, but if you are in China or in the US, maybe not. Because there are the regulations to protect privacy, data privacy, are soft compared to the European Union. In the European Union, there are very strict regulations, so all systems developed there have to respect that. So it means that we would need to implement cybersecurity measures to protect that information. So by doing that, yes. If not, no. Am I clear enough?
Yep. Thank you.
You are welcome.
All right. Thank you so much for sharing your data.
Pleasure.
So I'm not IT person and not going into your algorithm and all those things. I'm interested in the data that you have shared. Like you have mentioned, you can categorize the information, right? What type of information people are sharing. How can you, or can you model your algorithm in such a way that what type of information is most likely to fall into fake? For example, cultural news or like political news or business news. Which type of information is most likely to fall into false category? Did you check for that?
We focused on climate change only, which is some scientific application domain. You are talking somehow about political domain, socio-political domain. So we would need other kinds of ontologies for that, for example. The GPT-4 could be equally applied, yes, but we will need other ontologies, okay? So you would need to select
my concern
the
is
right ontologies.
if your system can detect, like, for example, in case of political news, most of the people are more likely to spread fake news, for example, during the time of election. For example, in case of personal issues, if somebody died, so people may not make fake news behind that because that is kind of more serious personal issue. So if we can categorize, or we can model the system in such a way that, okay, these categories are most likely to have, fake component. So that would be easy for common people to understand, okay, this domain is kind of gray and this is not. Would that be possible?
Yeah. It would be very easy. I mean, because if you use ontologies, you can relate to each other, okay, under a certain category. So, but we didn't do that in this. So could be done, but we didn't do it at all. Because we just used prefabricated ontologies. What you are referring is to build what is called ontology learning. Okay, so you build new contents of some ontology by depending on the text, on the data you have. But I mean, technically, can be done, yeah, without any problem. And then you could detect groups of people. I mean, what things have in common those people who have this vision of climate change, for example, politically, even.
Okay. And one more thing, just add on this. Did you see any sort of correlation, as you mentioned, that there is kind of temporal relation as well, right? In which time of the day people most likely to post fake news, like in the morning, in the night?
We
something
didn't
like that.
explore that.
Okay.
Could-
Or the
could-
month
again, it could be done, yeah, but we focus just on detecting misinformation and real news, real information. I mean, information grounded on factual knowledge. Just focused on that in our system. But again, it could be done, yeah, which would be very practical. Yeah.
Thank you.
You are welcome. Thanks.
Do we have any more questions to Doctor? Let me check online. Okay. So let us move to next session. So thank you very much, Dr. Rodrigo,